Okay, guys, this is part 3 of the Graphing Quadratics foldable. We're going to learn to solve these quadratics now by graphing. We've learned how to graph the two different types, and now we're actually going to find solutions to these quadratic equations, okay? How can a graph be used to identify the solutions of a quadratic equation? The solutions are always going to be what x is equal to, okay? Okay, it's always going to be when x equals a number, or where it crosses the x-axis. Sometimes we'll have 1 point, sometimes we'll have multiple points. All right, so the first thing we're going to do is solve this quadratic by graphing. Well, we know that we need to set it up so that our formula equals 0, or our equation equals 0. So x squared plus 5x. I need to move this 6 over to the other side, so I'm going to add it, make it a positive 6, and that'll equal 0. I'm still going to find my vertex, or my axis of symmetry. Okay, I'm going to substitute in my b and my a. So the opposite of 5 is negative 5 over 2 times a, which is, there's no coefficient, so it's 1, which equals negative 5 over 2. Negative 5 divided by 2 is negative 2.5. Okay. Then we have to find, or excuse me, step 2. We have to find the y to find that vertex. Okay, I'm going to substitute in the x that I found here for the other x's in my original equation. So we have negative 2.5 squared plus 5 times negative 2.5 plus 6. Okay, plugging it in right here.
So Joshua, can you come to my office and get a moment, please?
Negative 2.5 squared is is positive 6.25. Negative 5 times negative 2.5 is negative 12.5, and then plus 6, which all equals negative 0.25. Okay. All right, so that's our vertex, that's our y, that's our x equals, and our y equals negative 2.5, negative 0.25. Okay, now set up your table, our x and our y. We know our vertex is negative 2.5, negative 0.25. All right, I'm going to go, let's go negative 3, negative 4. We'll go to negative 2, negative 1. And we're going to substitute all that in. Sub in negative 4 into my equation. I'm going to get 2. Substitute negative 3 into my equation. I'm going to get 0. Substitute in 2. I'm going to get 0. And substitute in negative 1. I'm going to get positive 2. Okay? So they go ahead and graph these. Negative 3, 0, negative 2.5, negative 0.25, negative 2. Oh. Uh-oh. Hold on. This should have been negative 2.5, negative 0.25, then negative 2, 0, so that point was wrong. Sorry. And then negative 1, 2. Okay. Now, where does my parabola cross the x-axis? It crosses at negative 2 and at negative 3. So my solutions are negative 2 and negative 3. You can also tell by looking at when y is 0, what are my x's? Those x-intercepts there, okay, where it's crossing that x-axis. Number 2, go ahead and solve for your axis of symmetry. X equals negative b over 2a. Opposite of 2 is negative 2. Oh, and we actually need to move that 1 to over. So negative x squared plus 2x, and it'll actually be minus 1. because I need that 1 to be on the other side of the equal sign. So negative 2 over 2 times a is negative 1. Negative 2 over negative 2 is positive 1. Subbing in x wherever there is an x in my equation. Okay, 1 squared is 1, but times that negative on the outside keeps it a negative. 2, 0. So my vertex is 1, 0. And then set up your table. So my vertex is 1, 0. I'm going to let 2 before it and 2 after it. Substitute in 0, I get negative 1. Substitute in negative 1, I get negative 4. Substitute in 2, I get negative 1. And substitute 3, I get negative 4. And go ahead and graph it. Negative 1, negative 4. 0, negative 1, 1, 0, 2, negative 1, 3, negative 4. Okay, so the only place that on my parabola that crosses that x-axis is at 1. So the only y that is 0, the x value is 1. So my solution is 1. Or you can write x equals 1. That's my solution to this quadratic equation. Number 3. Okay. Again, we're solving by graphing. Go ahead and set this up equal to 0. So x squared, I got to bring that 4x over. It's going to be minus 4x. And then keep that plus 7 equals 0. Find your vertex, or axis of symmetry first, and then your vertex. The opposite of negative 4 is positive 4. And then there's no coefficients, so it's just 1. 4 over 2 is 2. And then substitute in everything. So 2 squared minus 4 times 2 plus 7. 4 minus 8 plus, I don't know why I put parentheses there, plus 7 is 3. And set up your x and your y table. Okay, we have our vertex is 2, 3. Go 2 points before it and 2 points after it. Substitute in 1 to get 4. Substitute in 0 to get 7. Substitute in 3 to get 4 and 4 to get 7. And then go ahead and graph them. 0, 7, like here. 4, 2, 3, 3, 4, and 4, 7. Now, where does this parabola cross the y-axis, the x-axis? It does not. So there is no solution to that quadratic. Okay. And then the last problem, it says find the zeros of f of x equaling this quadratic. I know it's a quadratic because of the exponent. Finding the zeros is exactly the same thing as what we've been doing. Okay, it's just finding where it crosses that x-axis. Go ahead and find your axis of symmetry. The opposite of negative 4 is positive 4. 2 times a is 4. So 4 over 8 is 1/2. Plug in 1/2 to everything. 4 times 1/2 squared minus 4 times 1/2. And then plus 1 equals 1/2 squared is a fourth. A fourth times 4 is 1. 4 times 1/2 is 2. and then plus 1, which is 0. Our vertex is 1/2, 0. I'm going to go in increments of half this time. So let's go to 0, and then negative 1/2. And then let's go to 1, and then 1 and 1/2. Okay. Substituting in 0, I'll get 1. Substituting in negative 1/2, I'll get 4. Substituting in 1, I'll get 1. And 1 and 1/2, I'll get 4. Okay. So we're going to go to negative half up 4. We're going to go to 0, 1, 1/2, 0, 1, 1, and 1 1/2, 4. Okay. The only place this parabola crosses the x-axis is at 1/2. So x equals 1/2, or just 1/2 as your solution. You do not have a left-hand page. Go ahead and make sure that you get this glued in, and you may work on vocabulary, or go ahead and review this. We're going to practice tomorrow in class.